So we have an improper integral here because if you notice, if we plug 4 in, we get a 0 in the denominator, so this is an unbounded integrand. So first thing we do is we change it to be proper with a limit. So the limit is we're going to use b as 4, and it's going to come from the left because it comes from inside the interval out to 4. Now, we could rewrite this as 4 minus x to the 1/2 dx, and we might decide to use u substitution here and let u equal 4 minus x, and then du equals a negative dx. Well, I don't have a negative already in there, so I'm going to put a negative in there, which means I'm going to put a negative, I'm going to put it all the way out front. I'm going to put it in front of my limit there. So that means this is going to be negative, and you can put a -1 if you like. -1 times our limit as b goes to 4 from the left. I'm going to change my limits so that, oh, and I forgot to put them in here, excuse me, 1 to b. Change my limits so we don't have to change them back later. So these are x values. So if x is 1, 4 minus 1, my new lower limit is 3. And my new upper limit, is 4 minus b. And this is u to the, negative 1/2, du. Sorry for that error. So we have -1 times the limit as b goes to 4 from the left. We can take our antiderivative now, which is going to be increase the exponent by 1, divide by the new exponent. Dividing by 1/2 is the same thing as multiplying by 2. From 3 to 4 minus b. What's going to matter is this limit once we plug our limits of integration in. So -1, limit as b goes to 4 from the left. And actually, let's pull that 2 out front too. So that'll make that a -2. We'll deal with it later. Now we're going to have a 4 minus b to the 1/2 minus 3 to the 1/2. Now clearly the 3 to the 1/2 does not depend on b. That limit exists. It's nice. Works out for us. Here is the interesting one. Now if I were to plug 4 in, I get 0. 0 to the 1/2 is fine. So this thing exists. It converges. We got -2 times 0 minus 3 to the 1/2, or square root of 3. Multiplying those together, we get 2 square root of 3. And this thing converges. Our improper integral converges to 2 rad 3.